All right, today we're going to look at your brain, but probably in a way you've never thought about it before. We're going to treat it less like some mysterious, magical box and more like a piece of software, something we can actually understand and maybe, just maybe, even upgrade.
So let me just ask you, straight up, is your brain running on outdated software? I know it sounds like a weird question, right? But it really gets to the heart of what we're talking about. The idea that our mental operating system might just need a patch or two. Okay, so here's the core concept, the big idea. Just think of your brain as this simple formula. Your output, your decisions, your ideas, everything you create, it's all a function of two things. That's it. The quality of the information you put in and the mental algorithm you use to process it. You change the input or you change the algorithm, you get a different output. It's that predictable, it's that simple.
So what is this algorithm really? How does it actually work? Well, let's pop the hood and take a look at the assembly line that takes raw data and somehow turns it into a brilliant insight. It's basically an 8-step pipeline. So information comes in through the input layer, right? Then your brain parses it, gives it some structure. Then it runs it through pattern matching, comparing it to what you already know. After that, it gets compressed to fit into memory, integrated with other ideas, and then synthesized to create something new. Then you get the output. And this is the crucial part. The feedback loop takes those results and uses them to tweak the whole algorithm for next time. It's constantly learning, constantly evolving. And here's a really fantastic way to think about this whole process. Your brain is basically acting like a software compiler. It takes the raw source code of reality, everything you read, see, and experience, and it runs it through those steps to produce an executable program. And that program, that's your decision, your action, or your next big idea. And get this, the analogy goes even deeper. Your short-term working memory, that's your computer's RAM. It's super fast, but you know how it is. It's also incredibly limited. Your long-term memory, that's the hard drive. It's huge, but it's a bit slower to access. And your mental models, the concepts you use to understand things, they're like APIs, these reusable blocks of code that help you make sense of the world quickly. But just like any computer, our brains are not perfect. They ship with some pretty serious hardware limitations, and they're prone to some very, very common bugs. And here it is, the most famous limitation in all of psychology, 7 ± 2. That's it. That's how many chunks of information you can hold in your working memory, your mental RAM, at any given moment. This one number is our primary cognitive bottleneck, and it explains so much about how we think. And that bottleneck, it leads directly to bugs in our mental code. You've got garbage in, garbage out. Pretty simple. If you feed your brain junk, you're going to get junk insights back. Then you have cognitive biases, which are like systematic errors in your logic, kind of like tangled, messy spaghetti code. We've all experienced working memory overflow, that feeling when you're just trying to juggle way too much at once. And then there's cache invalidation, which is just a fancy tech term for relying on old, outdated beliefs. The most important thing to realize here is that these aren't character flaws. They're just programming errors. And if they're just programming errors, well, that means we can debug them. And this, right here, is where things get really, really powerful. This is where we stop being just passive users of our minds and start becoming active programmers. So how do programmers find bugs? Well, they run something called a unit test. They test one tiny piece of code at a time to see if it works as expected. And we can do the exact same thing with our thoughts. Let's call it cognitive unit testing. You start by making a clear prediction. Then you check it against what actually happens in reality. And if your prediction was wrong, boom, you've just found a bug in your thinking. Now you can dig in, figure out why, and update that mental model. In fact, you can start right now with a personal code audit. Just ask yourself these 3 questions. First, the input audit. What information am I actually consuming every day? Is it high quality? Then the algorithm audit. What are the core mental models I'm using to interpret the world? And finally, the output audit. What am I actually creating with all this thinking? Is it producing real value? Auditing your code is great. It's essential. But that's just debugging. What if we could do more? What if we could perform a fundamental, system-wide cognitive upgrade? So here's the paradigm shift. This is the whole ballgame. Your biological limits, that tiny working memory, the fact that you forget things, they're not features of the system. They are bugs. And like any bug, they exist to be solved. Just thinking about it this way changes everything. It reframes our limitations not as permanent walls, but as technical challenges just waiting for a clever solution. And here is that clever solution. An external knowledge vault, your note-taking system, is not just a place to dump facts so you don't forget them. It is a version control system for your mind. Now, in the software world, that's a tool like Git that tracks every single change to the code. For you, it becomes a system to manage, track, and improve the source code of your own thoughts.
And look at how perfectly this maps out. Every time you capture a quick idea, maybe as a voice note, that's a commit. You're saving a version of your thinking. Later, when you sit down to organize and connect those notes, that's your code review. You are literally debugging and improving your own cognitive algorithms as you go. What you end up with is this incredible symbiosis. Your brain is freed up to do what it does best: recognize patterns, synthesize new ideas, and process things in real time. Meanwhile, your external vault handles what the brain is terrible at: perfect recall, unlimited storage, and keeping a perfect version history. Together, they create an extended mind that is so much more powerful than your brain could ever be on its own. So, we'll end with this thought. You've now seen the basic architecture of your mind's operating system. You can see the code running. The only question left is, what's the first line you're going to refactor?